I will be showing you everything you need to know in order to overstand and understand vectors and arrays in this video. My goal by the end of this video is that you fully understand these data structures so that you can start solving leak code problems, interview questions, and even develop in C++ with your own applications integrating vectors and arrays. To follow along with code snippets and a comprehensive guide, please check out my website down below. There you'll find a full-on entire guide in an easy to read format. So without further ado, let's get right into it. Okay, to start things off, we're going to go ahead and explain what an array is, and then we'll go on to vectors and that sort of thing. So an array is a collection of elements of the same type stored in a memory location. Okay, and once you set up the size of this array, you cannot change it. So in this example, we declare an integer array size 10. Okay, we can't change it. Now I'm going to go ahead and give you a little mental visual so that you'll be able to understand this more. And I'm going to walk you through the behind the scenes. So let's say we have an array named R, and we're going to have 3 memory locations, or 3 integers in this case. And at first you may be wondering, like, okay, what is inside of these? Like when you first declare an array like we did here, size 10, what's inside of here? Now it's garbage values. Okay, we don't know what's going to be there. It's just a random number, and we can declare, put values in here. So in this case, we're going to put 3, 7, and 4. And each array, that all arrays start at index 0. Okay, keep this in mind. And they go until n-1. And you might be like, well, okay, what's n? This is like a textbook thing. N would be the size of the array. So in this case, we have 3. -1 would be 2. So that would be the last value of a array. So 0, 1, 2. And this is how you can get the, this is how arrays work behind the scenes. Now, you may be wondering, okay, in the memory, where is this at in the memory? So arrays are contiguous or contiguous. You'll have to look that up. That's textbook naming. But basically what it means is once you declare an array, the first memory location will be, let's say, hashtag 1222. Okay, let's just say like that's the memory location. And from there, each memory location will be +1. So they're all like in order. Okay, so the first index is next to the second index, and that one is vice versa, and it goes in order like a train. Okay, now this is behind the scenes in the memory. Now, so for example, I'll just give you a quick run through. This memory location would be 1, 2, 2, 3. Okay, and then the next one would be 1, 2, 2, 4. And mentally, you can think of it like that. They're all in order. But the kicker is sometimes, let's say, for example, like in the memory, the address here is, let's go ahead and make this a little bit easier to understand. So like this is a good interview question. Somebody might ask this. But let's say it starts at memory address 1000. Okay. Now the next memory address, depending on the system, let's say would be, because integers are 4 bytes, would be 1004. Okay, and then the next one would be 1008. I just want to put that in there just in case you might, because bytes, 4 bytes, sometimes it'll be 8 bytes, but in most cases the compiler will be setting each array block as 4 bytes because they're integers. Now that we have that understood, let's go ahead and get into the code. So to declare an array, you can do this this naming. Go ahead and do your own studying, but this is how you just remember this. If you want to initialize the array with values, you can go ahead and initialize it using this =, curly braces, and you can assign different values while initializing it. So get rid of this, and now we have an array of size 10, and here are the 10 values. Okay, and you may be wondering, okay, well, what happens if we don't initialize it with values? I'll go ahead and show you a demonstration. So if we output array of 0, this will give us a value of garbage. And remember this, garbage. So when think of this like also when you declare an integer. So let's say we have an integer named a, and that's it. And See, the problem is if you don't declare it equal to 0, you might get a garbage value. And that's the same deal that's what happening here with arrays. In order to remove this or fix this, you can go ahead and initialize the array with values. Now, there's a couple tricks that you need to understand and know with arrays. If you declare the first or initialize the first index with 0, the rest will be 0. So all these will be 0, 0, 0, all through index 0 through 10, okay? Or 0 through 9. And then this does not work with, so if we output array of 1, okay, we will get a 0. This is because the first index is 0, and so the rest. Now, this does not work with 1. So you might be thinking, if we, declare it with 1, the rest of the values will be 1. This does not work. It will be 0. And I want you to understand this because this is where the mix-up. If you initialize a value, the rest will be 0, no matter what. So that's a trick if you want all the values to be 0. Now, when we get to vectors, you'll be able to understand this more, and you'll be able to manipulate this, and vectors give us more tools. So let's go ahead and get into accessing array elements. So if we have an array here of 5 elements, we can access it using indexes. So if we, if we access the 0th index here, we will get a value of 10. Okay. Now we can do the same using a for loop, which will go through all of the indexes. So in this case, we will see here that using this for loop, I starting at 0, because there's 0 base index, until we hit 4, so less than 5. So there's n minus 1 would be 4. So in order to modify array values, we can use the same syntax as we do to get or view the array, but instead we can make it equal to a value. So in this case, we have set the array at index 0 equal to 1. And so if we run that, we can see that here it's now set to 1. But if we can look at it before we changed, we can see that it's 10. So that's how you modify an array value. So that leads us into multi-dimensional arrays, aka a 2D array or matrix. So think of an Excel spreadsheet, and you have rows and columns. This is what a 2D array is. So this is how you initialize a 2D array. You use the rows is the first one and columns is the second. Just mentally remember this. So we have 2 rows and 3 columns, okay? And this is how it looks when you output it. You can get a visual. So I'm not going to get too deep into matrices, but this is how you declare a 2D array. Now, if we want to initialize it with values, we can do the same ordeal like we did with original arrays. So if we wanted to declare a regular array with values, we did with this with curly braces, array of size 10 with these are the values of each index. And here we can do the same thing. So 0, 0 would be 1, 0, 1 would be 2, and etc. So rows and columns. And so that's how you can initialize a matrix with values. So now that we have in a 2D matrix, if we want to, access the elements, we do the same ordeal, except we have row and column. So we can go ahead and test this. So as you can see, if we want to access the 0th row in the first column, so this is 0 row here, and then the first column, because columns go from 0, 1, 2. As you can see, is 2. 0, 0 would be 1, and then 1, 2, or 1, 1 would be 5. So that's how we access elements in a matrix. Now, if you want to loop through a matrix and we want to access all the elements inside of it, we can use 2 for loops. So basically a loop for the row, loop for the column. So as you can see, we have 1, 2, 3, 4, 5, 6, and I did the inline on each row. So this is basically everything you need to know about arrays, a simple explanation. The drawbacks of arrays are basically they're fixed size, meaning we can't add or remove values after we set it up. And then arrays, they can be accessed out of bounds, so you can access out of bound values, and you have to know the end of the loop or end of the array in order to loop through them. And there's not many built-in functions, so you can't sort an array, and a lot of it is manually done, which you can do your own research on that. But this leads us to vectors. Now, let's go over what is a vector. So a vector is a dynamic array that has built-in functions that allows for easier use and manipulation of data. So this is like your bread and butter when it comes to anything regarding a list, a vector, array. This is what it's going to be in C++. So you can have integers, characters, floats, shorts, strings, pointers, pairs, anything you can think of can go in a vector. So the first thing you need when you are working with vectors is the include. So go ahead and include it to your C program, C++ program. And to declare a vector, what you need to do is type vector, the data type that you want, and then the name of the vector. So in this case, we have a vector with integers, and it is named v. If we wanted a vector of floats, we can go ahead and type vector float f. So we now have a vector. So if we want a matrix of vectors, so a vector and a vector, we can basically type vector, vector, the data type that you're going to use, and then the name. So in this case, we only need to say that it's an integer. So 2D is arrays, or in a matrix, they have to be the same data type if you're going to do a vector. Now that we know how to declare a vector, if we don't know the size of a vector, we can go ahead and type this. We don't know the size. We don't need to know the size either. The computer will go ahead, or the compiler will go ahead and manage this for us, unlike arrays. Now, if we want to declare a vector with a certain size, we can just type, after we declare it, we can type in parentheses the size of the vector. Okay, so in this case, we now have a vector named v with 5 elements. Now, if we output the first index of a vector, since they work the same as an array, they are initialized with 0 at. So unlike arrays, how you have to specifically say what the value is, the value will not be garbage if you don't initialize the values. It will be automatically 0. I want to declare a vector and I want all the values to be 10. So to do that, you go ahead and declare the size and then comma and put the value that you want. So in this case, we now have a vector of size 5 with all of the elements will be 10. So if we go ahead and take a look at that, see index 0 is 10. And so all the values will be 10. Now we can also still use the method or way of declaring a vector and manually inputting the size. And instead of having to put the size of the vector before we initialize it with values, we can just initialize it with values. So this will be a size 10 with these values in here. Now, if you would like to copy a vector from another vector, declare it inside. So what do I mean by this? So say we have a vector of v1, size 5 with all the values of 10. If we want to copy if we want to make a copy of it, we just declare another vector, say v2, and stick the whole thing in there. And now we have a duplicate or copy of vector v1. So now that we know how to declare a vector, we can get to adding elements to that vector. So in this case, say we have an empty vector v and we want to add an element to the end of the vector. We can go ahead and do v dot pushback. Okay, this is one of the functions that's built in with STL. Now this will add a value, let's say 10, to the vector. And now if we do cout v of 0, we should get 10. And indeed we do. And say we want to add another value to the vector. So let's say 1, 1, 1, 1. We now have 2 values in the vector. So we have 10 and 1, 1, 1, 1. So this is how you add values to a vector. Now there is also another function that you can use instead of pushback. It is called inplaceback. So what is this? This is v.inplaceback. Okay, and then you add the value that you want. So in this case, let's add 15. And this will add a value of 15 to the vector, as we can see here. Now the difference between pushback and inplaceback, there's a few differences, but I'm not going to go down the whole rabbit hole. You can go ahead and do your own research. But in most cases, you're not going to be using inplaceback. Just about everyone uses v.pushback. Okay. Inplaceback uses some sort of constructor that uses a template. You can go ahead and research that on your own. But basically, if you want to add any element or value to a vector, use v dot pushback, okay? And this even works for strings. So let's say we have a vector with strings, and let's go ahead and add C++. Now if we output that, boom, we have a vector and the first element, or the 0th index, is C++. Now, you may be wondering, okay, well, we can have strings. Didn't you say we can do pairs? We can. So if we have a vector of pairs, so basically a vector, to declare a vector of pairs, like we said, you do the vector and then put your type. So pair, int. Okay, so now that we have the vector of pairs, if we want to add a value to the pair, or to the vector, we can just use v dot pushback, and then in the parentheses we have to do the type that we're adding. Okay, and so this will add the pair 1, 2 to the vector. Now you can also use in place back. I'm not going to go over that, but you may be wondering, okay, I want to see this. So if we see out v of 0, okay, we want to see this pair. You may be wondering, okay, why is it not working? This is because vectors, you need to have iterators in order to traverse a vector and output these special data types. So we could do it with integers, which was fairly easy. When we had integers here, we could just output it. But any sort of data structure that is within a data structure, you need to understand iterators. So this leads us to the most important part of this tutorial video about vectors, and that is iterators. So what is an iterator? An iterator is basically a thing that points to a memory address of a container. So I will get back to this vector of pairs. I first need to explain what pointers and memory addresses are. So I'll go ahead and declare a vector, let's say int v, with 5 elements. Now there are 2 functions that I want you to understand, which will make this easier to understand. .begin is a built-in function, just like .pushback, and this will return the memory address of the beginning of the vector, okay? So it will return this memory address. Like we said, with arrays, they start at 0. This will return that memory address. And v.end will return the end of the vector's memory address. So not 5 here, but the one after that, which will be like, I don't know, it marks the end of the vector. So remember these 2. In order to store that .begin, we can't just we have to have a memory address. So in order to get the value at that memory address, we have to use star. And this will give us the value of .begin. So using star, that will give us the value at any memory address. Okay, this is basic understanding. So now that we understand star, or basically to get the value at a memory address, okay, I'm going to explain the and sign. So this is basically a reference. So this is a simple explanation of pointers and references. So let's say we declare a integer x, okay, with the value of 10. Now to get the memory address of this integer x, we use the and sign, okay? Now if we want to get the value at that memory address, we do star. So if we declare a integer pointer, which will get the value at the address x, this will give us 10. So this is basically what we're doing with iterators. Now, I want to explain one more thing before we get into using iterators to traverse a vector. This is an example of toSum on LeetCode. Now, as you can see here, we have a vector, we have a function that returns a vector, okay? It's named toSum, and the vector is it passes a vector by reference, okay, nums. Now, you may be wondering, okay, well, the and sign means memory. That means that this here means that this num is the original vector from wherever it's at. So the and will point to the memory address, okay? And then we have target. So the vector nums is being referenced. It's not a duplicate. It is the original nums because we're passing the memory location, the reference of it. So that was basically a quick guide on pointers. I'll go more in depth on another video. But so coming back to our vector of pairs, now that we have a pair 1 comma 2 inside of our vector, in order to traverse this, we have to use iterators. So a easy way to remember how to traverse vectors is using this for auto it. Basically what we're doing here is we are having a for loop with it will automatically determine the type, so we won't have to type pairs or integers. It'll automatically determine what this vector is containing, and it's going to loop through the entire thing. Okay, and so here if we output the first value, so it.first, that would output the first value of the pair. it.second, this will output the two pairs, so the two values in the pair. And so this works with any type of data structure, and this is why we need iterators to traverse over a vector with these types of data structures. So now that we have a for loop here, see as we push back 1, 2, 3, 4, and it's going through each pair and outputting the first value in it and the second. And this works for hash maps, unordered maps, linked lists, any sort of data structure. You can use iterators. So one last thing about iterators, if we just remember this for loop and rule of thumb, if you want to iterate over a vector, so for auto it colon v. So you're creating an iterator it, and you are looping through the entire v vector or data structure. Okay, and you just see out it, and this will go over everything in this vector, and it doesn't matter what data type this is, it will go over and print it, and the iterator will mold itself to the values or the data type in there. So that's just a quick explanation of iterators. So now this leads us to the next function that you need to understand about vectors, and that is deletion or erase. So if you want to remove, let's say, this one of the vector, you can do v.erase, and say v.begin. So from now on, we have to use iterators with these functions. So now that we have erased this, we can do for auto it to v. So now we've deleted the first element, or the dot begin. Now, if you would like to remove a set of particular indexes, so for example, you want to remove 1 to 3, you go ahead and use v.erase. You want to add the start index, okay? And then you want to add the ending index. So let's say v.begin plus 2. So this will erase from the starting index 0 all the way plus 3. So 0, 1, 2, or 1, 2, 3. So you need to add the starting index and the ending index that you want to delete of the section. Now let's say instead of v.begin, you don't want to, you want to erase just the fourth index. You could just do plus 4. And this will, or plus 3, because it starts at 0. It will delete the fourth index here, or the fourth value. So this is useful if you know what you need to delete or erase. This leads us to insertion. So if you want to insert values inside of here, use the same type of syntax. So we could do v.insert, okay? And you want to add the beginning of where you want to insert. So if you want to insert something at the very beginning, you just do v.begin, and then you want to tell it what value you want to insert. So we want to insert 20 at the very beginning of the vector. So as you can see here, we have 20 and then 1, 2, 3, 4, 5. Now, if you want to insert more than one value inside of a set, like in between some of these, so let's say we want to insert the 20 in between the 2 and the 3. So we'd have to do v.begin plus 2, and I believe this will insert it. Yes, so we have 1, 2, and then the 20, and then the 3. So you tell it what location to insert the value at, and then the value you want to insert. Now, if you want to insert multiple 9s in between here, okay, you just want to first tell it where to start inserting, tell it how many times you want to insert that value, and then the value itself. So now we have inserted 10 counts of 9 in between 2 and 3. So as you can see here. So that might be useful. Now if you want to insert a vector inside of a vector, which sometimes you need to do, you can do that as well. So let's say we have vector v2 and vector v1. And we want to insert v2 inside of v1. So this would do v dot insert, v dot begin plus 2, v dot begin, okay, v dot 2 dot end. So basically what we're doing here is inserting the entire vector v2 begin and end inside of the first vector. So as you see here, so at index 2 we are inserting 7777 or 777, as you can see. Now this brings me to the most important vector functions. These are the functions that you're going to be using almost every time you use a vector. If you skip over these, they'll leave knowledge gaps. So make sure you understand these next few functions, STL functions. So the first one is v.size. Now, if this will give you the size of the vector, okay? So in this case, we have a vector of 5 elements. So size 5, v.size, okay? This is very useful in loops, which I'll be going to over in a second. Now, if we also have v.empty, this will return if the vector is empty or not. So this would be false, 0. And then we also have v.popback. So we have a vector, and v.popback will remove the last element. So as you can see, we have 1, 2, 3, 4, 5. If we output this, we have removed the last element, v.popback. This is very very useful. Now, if you want to remove the first element, you just do v.erase, v.begin. So there is no pop front. You could just use this. And this should remove the first element. Oh, let me add the, there we go. So this removes the last, this removes the first. And the next one is v.end. So like we have v.begin, we now have v.end. And this is good for loops. So if you want to do a simple loop over the vector using just a regular iterator, you can use v.end and v.begin. So what are we doing here? We do auto it at v.begin. So this is like I equals 0. So v.begin until the iterator hits v.end it++. And this will output the value pointing at the memory address here. So what I was showing you earlier is basically a simpler version of that. So for auto it to v, cout it. Boom. And so basically you get the same thing, 1, 2, 3, 4, 5. So pick and choose your poison. I prefer to iterate over vectors using this. So now let's see vectors in action. Okay. The problem to sum on LeetCode, I want to show you this explanation. So go ahead and take a look at TwoSum here. Go ahead and read this. I want you to be able to do it yourself. You should be able to understand this now using vectors, the and sign and all that. So here we declare a answer vector. So basically the return of this function. And we want to get the size of the nums. So we store that in integer n, and we get nums.size. So this will get us the size of the vector. Then we loop through 2 times, okay? Or we loop through each value to get the difference. You could read the problem, you'll understand what's going on here. And then if we find our winning condition, we add that value to the answer vector using pushback, and then we return the vector. So I hope you understand vectors and arrays from this video. If you did not, please check out the link in the description, which links to my website, which contains just about everything we went over in this video today, empty, which more in-depth, comprehensive. I written out multiple code snippets and even gave you problems to solve. So please check this out. If you didn't understand anything, it has more clarification. Don't forget to like, comment, subscribe, and I will see y'all in the next video. Peace.